Transition matrices, part 1, more exam examples, because you need lots more of those. This is always a big part of the exam. This is 2018 Exam 1, question 8. It says we've got a public library with 500 members in these 5 categories, and we've got a transition matrix T, which they've given us. And then in the question, it says, in the long term, which category is expected to have approximately 96? Well, there's our lovely key phrase here. That means steady state. And that means we want a situation where, say, we can't work out S infinity. We're going to say S25 equals S26. Now, to do S25 and S26, we remember our formula that Sn equals T to the n S naught, so S25 equals T to the 25 S naught. But our problem here is, what's my S naught? But if you remember from my previous videos, in steady state, it doesn't matter what your S naught is. You can put in any numbers as long as they total to 500. Well, the easiest S naught you can use is just have them all equal 100, because we've got these 5 categories, 100, 100, 100, 100, 100. Again, that's just to make the maths work. So now we've got everything we need. We've just got to stick that in the calculator and see how it goes. Now, when you're putting in a big thing like a 4x4 into your calculator, you don't have to put in 0.10. You can just put in, 0.1, and your calculator is quite happy to then be nice and put the zeros back at the front here. So there's my T I've put in there. You don't actually have to label it for this question, but I'm going to just to make it easier. So here, this is me putting into the calculator that T to the 25 S naught equals S25, which gives me those numbers. And look, there's my 96. So if I label these J, K, L, M, N, it looks like K has given me the 96, which is the number we were looking for. On an exam, it's pretty much certain that S25 is not going to change when it comes to S26. It looks pretty much like that is the right answer. But if you must, you can very quickly change this. All you've got to do is just change that 6. So tap your screen and change the 6. And by no surprising coincidence, 96 is still 96 when you round it off. The answer is still B. All right, 2016 Exam 1, question 7. And it says we've got a situation here. We've got 300 students and we've got ourselves a lovely transition matrix. And then it says, based on the information above, it can be concluded in the long term. What does that mean? That's our old friend steady state. All right, so before we can do anything, let's just work out the steady state. Wait a minute, they've done the same trick again. They haven't given us S naught, right? So, but we've got 3 groups, A, M, and S, and we've got 300 students. Let's just use an S naught equals 100, 100, 100, yeah? And we should be fine on the calculator then to check out what's happening with A, B, C, D, and E. So there you go. I've taken my T and I put it in here as T. I took my 300 students and I just split them up into 3 lots of 100. That's the easiest way to do it. It does not matter as long as the total must be 100. So that total definitely is 300, but you can put any numbers in there and it'll still work out right. I've done T to the 25 times S to get me what I want, and I've got some values here. Okay, just to prove a silly point, I did actually do term 50 and got the same numbers. All right, so now we can start looking at the multiple choice and seeing what makes sense. All right, so if we look at A, it says no students will choose sport in the long term, right? Well, let's have a look. We've got to make sure we labeled our diagram. So A, M, S. So there's definitely there's 86 students in S. So definitely there are still some students who are choosing some sport. Let's have a look at B. All students will choose to stay in the same activity each week. Well, that's your leading diagonal of your transition matrix, right? And that would only be true if it was 1, 0, 0, 0, 1, 0, 0, 0, 1, i.e. the identity matrix, it was a hidden identity matrix sort of thing. If you're going to choose to stay in the same activity every week, then it'd be 1, 1, 1, 1 on the transition matrix. It's not, so B is wrong. Now, C says that all students will have chosen to change their activity at least once. There's no evidence for that. What it's saying on that leading diagonal is that half the students stay in art. So lots of people stay in art. You could have one student out of your 105 here who just stays there in art every week. There's nothing in the maths that says that's true, but you might not be as confident or clear in understanding that. So in that situation on an exam, put a question mark next to C, and then you might be able to work out one of the other answers is definitely right, and then you'll be going, oh, well, it can't be C then. So a lot of people on this question, when they were answering it on the actual exam, did sort of freak out with the wording of C and actually choose it. Let's have a look at D and E. D says more students will choose to do music than sport. So it's saying this is my music and this is sport. Well, that's 110 versus 86. So it actually does look like that is correct. That in fact M is greater than S. All right. Let's have a look at E. Whenever you're revising, check out what all the multiple choice questions are. So let's have a look at E. The number of students choosing to do art and music will be the same. So music and art, they're not the same number. So that's definitely wrong. And we can feel confident about D. Even if you didn't quite understand what C was about, D is definitely correct. But the reason that C is definitely wrong is that half the students can stay exactly where they want in art, and 40% can stay exactly where they are with music, and another half of them can stay in sport. You can just keep doing them forever and ever. There's no reason why when half changes this time, it's the other half that changes next time. It's just half of those students you have at that point. So we have a matrix recurrence relation. We've got the S naught, and then the next term equals T times Sn, and they've given us T. They've given us S1 down here, but what they haven't given us is the values for X, Y, Z, and V and W. So we can't do anything down here until we get those things and work out then which one is not true. All right, let's have a look at what we can do quite quickly and easily. We know the columns must add to 1. All right. Well, we can't do anything about the last column, but this column, 0.3, 0.2, that's 0.5, so X equals 0.5 as well. 0.2, 0.2 plus Y equals 1, so Y equals 0.6. That was fairly straightforward, but now we're going to get V, W, and Z. So we've got to write this out. Let's have a look at this. So we know that S1 equals TS naught. And we know what S1 is. They've given us that. That's 29, 13, 33. And that equals our transition matrix, which is 0.3, 0.2, V, 0.2, 0.2, W, 0.5, and 0.6, because we've already solved that, and Z. Make sure my Z doesn't look like a 2. And that's when you times by S naught, which was 40, 15, and 20. So remember that when you do matrix multiplication, it's this row by this column is going to give me this, right? So I can actually write out a whole statement that wrong color here, just bear with me, 0.3 times 40 plus 0.2 times 15 plus V times 20 must equal 29. All right, so just to run you through that one more time. Put that number back there, sorry, just leave 0.2. Remember, because it's the row by the column, so it's 0.3 times the 40, 0.2 times the 15, and V times the 20 should equal the 29. And this is going to be true for all the other ones as well. We're going to have 0.2 times the 40, 0.2 times the 15, W times the 20 equals 13, And then we're going to have 33 is 0.5 times 40, 0.6 times 15, and Z times 20. We're going to do all that in a minute. All right. All right. So we can do this on the calculator. Now, I know some of you aren't very good with your algebra for whatever reason, but that was our statement that we put into the calculator there. And then, well, just use the solve function. So here we are. We know for a fact that this row by this column is this equation and should equal 29. And that's what I've just put into the calculator there. And it got me v equals 0.7. So that's pretty good. And then for the next one, it's fairly straightforward. It's going to be this row by that same column gives me this value. So all I have to do is change the 0.3 to 0.2, the 0.2 and the v to w. Sorry, I've got to change the 29 to 13. It's got to come up on the screen in a minute, and you'll solve it for that one. And same thing again, if you were to do this one, you just have to change some of those values. So just have to plug in those values. So the 0.3, the 0.2, and the V, and the V, and the 29 will change. So let's just go through this slowly, just to highlight what's going on here. This row by this column gets me this equation, but I need to use the solve function to get my answer for V, which was 0.7. All right, so that's where we get all the values from. That's the 29 is from there. All right, then if we look at the next one, all I did was overtype this on the calculator. So I've taken various screenshots, but just overtyped. This equation is because it's this row by the same numbers, 40, 15, and 20, but this time they equal 13, and we're solving for W, and we got 0.1. Pause the video if you need to. And then this row by this column got me this value, which is all shown here in this column here. And so now we've perfectly worked out what V, W, and Z are. All right, so let's write those values in that we got. So V is in fact 0.7, W is 0.1, and Z is 0.2. We didn't actually have to do the third one, Z, because we know it's got total equal 1, but it's always a good double check, especially on a question that's a tricky question that a lot of people get wrong. And so we look at this, and it says, a W is greater than Z. Remember, we're looking for not true as well, one of those lovely double negatives. So W is not greater than Z, so it actually looks like straight away that is actually our correct answer. But as always, when you're doing multiple choice, it's always good to look at the other ones and see what's going on and double check when you're revising. So is Y greater than X? So Y is greater than X. That was too easy because remember we've got Y and X up there. So that one is wrong because it's true. Let's have a look at the next one. V is greater than Y. So V is greater than Y. That is true. True is wrong in this question. Next one is V plus W plus Z equals 1. We'll use that to work it out. It does actually work out V plus W plus Z equal 1. So that's true, which means it's wrong. Hate these double negatives, don't you? And then the last one is that X plus Y plus Z is greater than 1. Then there's no reason, there's no special magical number for rows to add up to. So you should always be suspicious of that one. But if you actually do add them up, 0.5 plus 0.6 plus 0.2 is 1.3. It is true, therefore wrong. Now, this is from the 2018 exam 2 from last year, question 3. And a lot of people made a mess of this. And let's read this carefully and see what words we're looking at here. So it says, of the length of high that was graded G in 2018, and we know that this represents 2018. S0 is 2018. So we're looking at then what bit was G. How many kilometers are expected to be resurfaced the following year? So we want to know of that G. Now remember, of that G this year, right, some of it's going to go to G, and some of that G is going to go to R, and some of it's going to go to S, and some of it's going to go to N, right? But we just want to know which bits of the G are going to R, which is just that value. So what people made a mistake was that they did the whole thing, but really all they're asking you to do is 0.1 times 700, because 10% of the G is going to R next year, and that equals 70 kilometers. Don't forget to put the unit. All right. Surprisingly, only about half of people got this right. So now we've got to show that the length of highway that is to be graded G in 2019 is 460 kilometers. They've given us the value. This is one of those self-correcting questions. If you don't get the right answer, it won't work. Now, we've got this situation that S1 equals TS0, right? And this is 2019, and this is 2018. We're not have to hit the calculator yet because we just want that first element, which is the G, right? So we want, remember it's T by S, so it's T by S to give us the G. And so we just take those values off that first row, which is 0.2, 0.1, 0.0, otherwise known as 0, and then 0.2. And if you put those numbers in your calculator, you will actually get 460, so you know you've got the answer right. You got yourself 1 mark. Now, finally, in part C, they're actually asking us to do the recurrence relationship, which is that S1 equals TS0. So this is the time to hit your calculator. But look, again, it's self-correcting in a way because you got the 460 and the 1490. You're only going to find these two values. So if you get the 460 and the 1490 wrong, then you know that your R and S values are going to be wrong too. So grab your calculator, and we've got our S here, which I've put in here. And I got my T here, which I've put in here. And so all you got to do is do T times S. And so once you do 2 times S, you get these values, and then you just have to do the very technical part, which some people still get wrong sometimes, 390 and 360. Write those in, and we're all done. Another easy mark. Okay, this is definitely one to pay attention to because a whopping 83% of people got this one wrong on the exam. So let's just review where we're at. We had a look at S1 equals TS0, where S1 is 2019 and S0 is 2018. Now, we got some values for this, and we worked out that this gives me a matrix of 460, 390, 360, and 1490. And this is our GRSN. Now they've given us some values over here that in 2020 we've got some an N value. We haven't got anything else, but they've given us that, and that's all we need. So in 2020, S2 equals TS1. And in this case, that means that's 2020. And if we put that into the calculator, we would get, I don't know, 1536 GRSN. Now what people got wrong is that this 1536 represents some G that became N, some R that became N, some S that became N, and some N that became N. So it had four sources going in here, but it says if you had no maintenance in 2019, what percentage is expected to then contribute to the no maintenance in 2020? So we don't want all of this. We just want the 0.5. We want the bit that went from N to N. And that's half of it, 0.5. So what our actual value is actually 0.5 times 1490. 1490 over 1536. And if you put in the calculator, you get like 0.485, blah, 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 blah. And putting that percentage is 48.5% to one decimal place. Why do we do that? Well, it's because it says there in the question, make sure you do what percentage to one decimal place. So what most people got wrong on the calculator was they just did the 1490 divided by 1536 and got 97%, which was the wrong answer. You need to do 0.5 times the 1490 because of this 0.5. That got you 745. Divide that by 1536. You get that as a decimal, and you should be able to do that in your head, really, that it is 48.5%. All right. There's a lovely magical keyword right at the beginning of part E, in the long term. What does that in the long term mean? Steady state. And so I like to do S25 and S26. Some people do S50 and S51. It's fine. So S25 equals T to the power 25 S0. And then I double check. It's a bit pedantic. You don't really need to do it that often. T26 S0. If these two are the same, then you've got steady state, and then you've got to do a couple other little number crunches to get this right. Looks like a job for the calculator. So here I go. I've already had my T and my S put in there, and then I just did T to the power 25 times S, got these numbers, and then remember, you don't have to like retype anything. All you got to do is attack that little 5 there and make it a 6. If you're doing 50, you could just change the 0 to a 1 and see if the numbers change. To be honest, you don't really need to do that unless they're saying prove it. But really, by the time you get to term 25, you're good. You're going to get the values. Unnecessary as it is, term 26 does work out like this. The numbers haven't changed. Remember, this is GRSN, and we want the percentage of the total network. Just remember that total network number comes from up here. So we want that number 1532 because that's the one that's N over the 2700, and we're going to make that a percentage to one decimal place. So 1532 divided by 2700 got me 0.5674074,074. I'm pretty certain that 074 is going to go forever, which is 56.7%. Actually, people did much better on that one than the previous bit. Now, again, you can see we've got transition matrices again. Just want to highlight a thing here. It says will not change, and I said this in a previous video. This leading diagonal represents the students not changing. So when we're using this formula over here from term 1 to term 2, in our numbering system, this is term 1. So term 2 is going to be S2 equals TS1. So this is going to be term 2, and we want that leading diagonal multiplied by this. So you end up with 0.4 times 300. That's 0.4 times the 300, and 0.4 times 200, and 0.3 times 200, and 0.2 times 300. Put that on the calculator, you'll get 320. All right. A lot of people got stuffed up by the numbering system because they're used to, this dude over here being S0 for term 1, but it was actually S1 for term 1, S2 for term 2. And you might have spotted if you've made a mistake on the previous part because it says complete S2, which is for term 2. So S2, it looks like a job for the calculator. So this is T, I've put it in the calculator. This is S1, put it in the calculator. So S2 equals TS1, which is what I've written basically here. And you get these values here. So you type them over here, 250, 250, 300, and 200. Now, I've done a similar question to this earlier, and it was even more disastrous in this one. 86% of people got this wrong. Wow. So pay attention to this. It's one of those ones. Of the senior students expected to choose investigations in term 3, what percentage chose services in term 2? So you've got to look at when you're looking from, we're going from investigations in term 3 from services in term 2. So it's services to investigations, yes? Because, and it is confusing. If it's this term, that would be term 2, and this would be term 3. So you have to know that term 2 was S and term 3 was I. So the percentage we're looking at is 0.3. That's a very important thing. But we've also got to know that we don't actually have term 3. So we've got to put all that in that calculator and crunch those numbers. Okay, so let's have a look at this. Remember, this is S2 and this is S3. And all I've done is add a power 2 here to take me up another one. It can be a bit confusing with the naming in this. So that was S1 equals this, and remember T S1 equals S2, and T squared then is going to S1 equals S3. You could have done this time T S2 equals S3 as well. That's another possibility, but I just did the shortcut method to get S3. Okay, now remembering that we want the kids who were S in term 2, so this is term 2 going to term 3, and that's 0.3 of them that went from S to I, so S to I. It's a bit weird because I've given you the term 3 before term 2, so we know it's 30% of the guys in term 2 who were S. So we've got CIPS, and so it's 200 in term 2, 200 were service. So it is going to term 3, 0.3 of the 200, which is 60, became investigation in their choice. Then in term 3, CIPS, there were 240 doing investigation. So 60 of them came from S. So 60 out of 240 equals 25%. And again, 86% of people got that wrong. So pause, rewind that bit again and have a think about it. So let's just review quickly that what the point was is we were going from S to I, and that was only 0.3 of them. In term 2, it was 200 of them were S, so 0.3 of 200 gave them 60. In term 3, 240 of them were I, so 60 of that 240 came from S in term 2. Hope that makes sense. Get that one right, and you're going to get a really good mark. Now, here's another one that just really threw people, and almost, I think, half the people got this wrong. There's a little bit of a trick. It's one of the last questions, so you know this is when you start to think about your question rather than overthinking earlier on. Maximum number of senior students in investigation at any time during 2018. So what we need to look at is what's happening with our numbers, and any time during 2018. So that's term 1, 2, 3, or 4. So we got values for investigation during that time. Now, it doesn't say steady state or even in the long term in this. It just says for term 1, 2, 3, and 4. But you can see that actually we're talking about investigation. So investigation, it's CIPS, CIPS, CIPS. And so this, just to remind us what we got here, this is S1. this is S2, and this is actually S25. I just did that to see what was going to happen with all this. All right, we could have done S3 and S4, and then just had to find the maximum number. But you can see that investigation is 200, then it's 250, and you can see that over the long term, it just goes to 239. So what people often did in this question was they wrote 239 because they thought that was what they're asking. They're asking for the steady state. But if we look at those numbers, which one is the maximum? Well, the maximum is 250. Just delete that because that was the maximum 250. So sometimes when you get these things, they kind of bounce a bit before they hit steady state like this. And so it's actually bounced up and then down and then wiggled out to a steady state situation. But a lot of people made the mistake and went straight to a steady state. What you really should have been doing is looking at S1, S2, S3, S4 and seeing which one had the biggest I. So only half the people got that one right.